We've already seen this equation in the past. So x is in play, y is in play, z is not in play, z is not in play. So we would ignore this axis and just look at the xy axis. So looking at this, it's a circle. So imagine this is a perfect circle. Because z is not in play, it's going to get dragged. Get dragged in the z direction. So as a result, it will give you a cylinder in 3D. So we've already seen this. In this video, we're going to try and understand this equation in 3D. So before we do that, let's just give you a reminder. Let's say you've got a function f of x equals x squared. It will look like this. If you apply this transformation, so you've got a function f of x equals x squared, and x squared, and it looks like this. If you apply this transformation, this would then, hang on, let me clear this up. So at the moment you've got x squared. If you apply this transformation, you would put this into here, so that would become 3x squared. Well, this transformation, remember this transformation, well, so from here to here, you would cut up into three equal pieces. This transformation would actually give you this. It gets squashed by a factor of 3. So everything gets squashed together. So as a result, applying this transformation would then give you this. And we've seen this in the past. If you apply this transformation, so currently you've got f of x equals x squared. Apply this transformation, put it into here, so that will then give you this squared. Tidy this up, that will then become this. Well, this transformation will do this to the graph. So currently x squared looks like this. Applying this transformation, hang on, 1, 2, 3. Applying this transformation, 1, 2, 3. Applying this transformation will then give you this graph. So this transformation would squeeze it inwards. This transformation would then stretch it outwards. As a result, it would then give you this. So going back to here, so if you have this function and you apply this transformation, it will then give you this. Tidy this up, it will then give you this. If you apply this transformation, so currently this is y equals x squared. If you apply this transformation, it will move it by a factor of, let's say, a here. So your graph will look something like this. Okay, so going back to here, so this is your equation for a circle. Well, x over a squared will then stretch it in the x direction. So that will then take you to a. So this thing here will then give you this, and then apply the same process to the y. So apply the same transformation to the y. That would then, so normally it was at 1, negative 1, but you applying this transformation where you have this, it will then stretch it to b. So this equation here will then give you an ellipse. It will then give you an ellipse. So going back to 3D, x is in play, y is in play, z is not in play. So in your mind you would discard the z axis and then just draw this on a flat surface. So on your flat surface on your flat x y surface, you would then draw this ellipse, and then because z is not in play, it gets dragged in the direction of z. So it gets dragged all the way up here. This thing here gets dragged all the way up here. So then it will then give you this cylinder where this is an ellipse. Okay, so just bear this in mind.